4 out of 6. So 4 out of 6 of those. Now that's not how I do these problems. What I do is I write down the numbers, and I circle all the odds, and then I circle all the primes. So how many did you circle? 4 out of 6. But all we're trying to show you, because the probability does get more complicated, that if you're doing the probability of A or B, the mathematical formula is take probability of A plus probability of B, subtract out the events or the probability where both of them occur. But for simpler problems, I would just do it that way. Does that make sense? 4 out of 6, which equals what, 2/3? A card is selected from a 52 card deck. Okay, so we're back to my cards. What is the probability that a diamond or a king is chosen? So the formula is going to be probability of a diamond plus probability of a king, and we're going to subtract off any cards that are both diamond and king. Right? How many of these cards are diamonds? Yeah, 13 out of 52 are diamonds. There's that. Right? So remember, these cards, the possibilities are these. Right? There's 52 cards. So there's 13 of these, 13 of these, 13 of this symbol, 13 of this symbol. So yeah, 13 of them are diamonds. 13 out of 52. How many of these are kings? Four, right? So the probability of getting a king is how many? 4 out of 52. Are there any cards that are both diamond and king? Yeah, this one. So we accidentally counted it twice. We counted it as a diamond, it as a king. That's only one card. You can't count one card twice. So we need to subtract off. There's only one card that's both king and diamond. So you need to subtract that off. Doing the math, common denominator of 52. 13 plus 4 is what? 17 minus 1 is 16. We reduce that, get 4 out of 13, which is 0.31, 31%. Okay. Does that make sense? So that's why we subtract it off, because sometimes you have something that's both. So you don't count it twice, you need to subtract it off. If there was 2 cards that were both diamond and king, then I would subtract off 2 out of 52. Okay? Questions? Now me, I use this formula all the time, and then I just cross this part off if I decide that you can't have, like if they're mutually exclusive, then I just cross this part out. If they're not mutually exclusive, then I include it. What did we learn? We learned the probability of a second. I don't know how that sounds. We how can I write that in words? Because I have on the board, find the probability. It's not very specific. Maybe we say solve or compute probabilities involving not or right? That's more specific. So probability of not, probability of or, how do you work with those? Rate yourself. We should be able to do this one. And your homework. If you haven't had homework in a while,